Okay, I'm just going to bang this one out just to help you. This is more of an understanding question. I'll do some differentiation, but I'm not going to go through every single step for this one, just to show you very quickly compared to the length of the other videos. Show that the curve y equals, this is question 14 by the way, 2 over 1 plus x has no stationary points by considering the domain and range of the function. Okay, in case you've forgotten, this type where you've got the variable x on the denominator is going to have an asymptote where it cannot equal 0. This cannot equal 0 to some extent. So, sorry, the denominator cannot be 0. If we make x negative 1, 2 divided by 0, which that would be, is an impossibility. So, just to show you, 2 divided by 0, maths error. We cannot do this. Okay? So, we definitely know that x cannot, in this function, cannot equal negative 1. Okay, so we have an asymptote. So if I'm drawing that straight away, and I have my 0, my negative 1, I know the function cannot equal that. Okay, it can be this side, it can be this side, it can be do whatever, but it cannot equal x equals negative 1. Okay, at this state. Also, if I'm going to, I can do this a few different ways. I can do a table of values and show you what the points will be. I'm going to do that in a moment. The other thing I want to quickly show you that the textbook refers to is they differentiate this, and I'm just going to help you do that. I'm actually going to put it into a form that I find a little bit easier. If you've done Rubik's Cubes, with Rubik's Cubes, how you treat them is you can break some section off and work on it and then bring it back. Similar with building a motor. With this, I'm breaking this apart and separating it, and I can join it. It's still glued together, still the same thing, but I like to tinker with this a little bit and then bring it back. So what I'm going to do here is 2 times 1 plus x negative 1. This is the same as this is up here, it's just in a different form. And I can include my 2 next to it, in fact. Same thing. Okay. Now I'm going to differentiate that. Y dash. I'm going to bring down that 2 minus 2 is going to be 1 plus x. That's going to be 1 minus that, so it's going to be minus 2. The differentiation of the inside is just going to be 1 because I've got an x times that. I'll just put that just for that sake. So it equals negative 2, 1 plus x negative 2. Now I can put the 1 on top and change it back to its original form. And put that negative 2 up there. Now, this cannot equal 0. Okay? Because so the curve has no stationary points. So just on our rationale that we had before, just as we couldn't have negative 1 equal 0, we can't have this, our bottom denominator here, equal 0. Okay? So this cannot equal 0. Because if we were finding a stationary point, let's just say y dash equals 0, we go 0 equals minus 2 over 1 plus x squared. If we were to, let's just times by that, that would still be 0. 0 times that, you'd have 0 equals negative 2. Hence, this is true. There are going to be no stationary points on this curve. Okay? So I've kind of gone up there, proven that, and then come back down. Sorry, kind of jumped the gun there a little bit. If I'm going to sketch that, I probably need a table of values. I should show you how you're doing that. Let's just do another piece of paper. I'm just going to do either side of that negative 1. I'm just going to go do a few here, do a few here. What you'll end up is like a curve that will be going up like that. Oh, sorry, down like that, and up like that. Okay? So, I'm just going to pick some. I know it can't be negative 1. So I'm going to say x and my y's I'm going to start with negative 3, negative 2, can't be negative 1, that can't be work, 0, 1, 2, and 3. Okay, so here, if, remember my y dash 2 over 1 plus x, I'm just going to put that in my calculator, over 1 plus, I'm going to put negative 3, it's going to be negative 1, I'm going to put negative 2, it's going to be negative 2, if I put negative 1, it should come out with a problem, yep, can't work, or NA as we like to write it, 2 over 1 plus 1, it's going to be 1, oops, sorry, that should be 0, 0, it's going to be 2, that's going to be 1, it's going to be 2 over 3, and it's going to be half. Okay, so what we're starting to see here, if we do this in a quick table of values, is we've got our, it's coming up, I really should do some more, let's do one more real quick, let's do negative 4. Negative 2 over 3. Okay, so we're starting to see some symmetry here. We've got negative 2 and 2, 1 and negative 1, 2 and over 3, and negative 2 over 3. If we did 5, it would be negative half as correlation with this half. And if we're sketching that on here, can't work on negative 1. At negative 2, it's going to be negative 2, so that's going to be down here. At negative 3, it's going to be negative 1. At negative 4, it's going to be 2/3. I really should try and do something in between. What's going to happen? It's going to sketch up like this. And the other one, at 0, it's going to be 2. At 1, it's going to be 1. At 2, it's going to be 2/3. At 3, it's going to be half. And you can see, okay, it's sketching up like that. Okay, I really should show you a little bit closer to this if you start doing probably, what's the numbers between here, like negative 1 and a quarter or negative 1 and 3/4, it will get infinite and closer and closer and closer, but sorry, bigger and bigger and bigger. It'll get a big number. So just to prove to you, I'll show you. I'm going to go like even 3/4. So it was 2 over 1 plus negative 1 and 0.75. It should be a big number. No, it's not that big. Maybe I'll go bigger. Let's go. No, I don't want to do that. I want to. Oh, I want to be closer. Let's go with that. That's going to be a big number. Sorry, 1.1. So 1.1 is going to be here, somewhere here. So it's going to be negative 20 at 1.1. And it cuts all the way down to 2. And if we make that even smaller, that's going to be 200. So even a slight change is going to be a really big number. So you're going to keep going right down and right up, but we'll never actually touch negative 1.